Hello students, myself Rakhi, Assistant Professor in the ABS Engineering College, Ghaziabad, affiliated to Dr. APJ Abdul Kalam Technical University, Lucknow. Today in the lecture series of Microwave and Radar Engineering, whose code is KEC 074. I am going to introduce this subject to you, and this is my introduction lecture. So, the content which I am going to cover in this particular lecture is the syllabus of the subject, course outcome of the subject, and introduction to microwave. Now, first of all, before going through the syllabus of the subject, I just want to tell you this is the elective subject which is applied in the Electronics and Communication Engineering branch in the 7th semester, and in this particular subject comprises of 5 units, and the first unit is here with you. In the first unit, we are going to study about the transmission line. The transmission line, already as we know, that is the medium which is used to transfer the information from the source to the destination, and there are various types of transmission line, and here we are going to have one of that. So, transmission line equations, which is and its solution, reflection and the transmission coefficient. Whenever the signals are get transmitted, and there is a probability that it will get reflected. So, what will be the coefficient over that? That is, what is the relationship between the reflected signal and the incident signal? What is the relationship between the transmitted signal and the incident signal? All this will be covered in the reflection and transmission coefficient. Then comes the standing wave. Standing wave is one of the most important parameter which comes into existence whenever we talk about the transmission, reflection and the incident wave. The standing wave is basically what? Whenever the signal is transmitted from the source and is about to reach the destination, there is a one waveform which is formed. But if this is the incident one, but when this is not possible that all the incident signals will get transmitted, there is a probability that some of the signal is reflected back. The signal, the wave which is formed by comprising incident and the reflected wave is called the standing wave. So, we are going to study in detail about the standing wave in this particular unit. Then the standing wave ratio. So, as we know, this standing wave ratio depends upon the reflection coefficient, because it depends upon the reflected wave. So, we are going to study about the standing wave ratio in this. After that, we will go to the line impedance and the admittance, because as we know that the impedance and the admittance which is comprising in the transmission lines plays a vital role during the transmission process. And after that, we will get into you will be get introduced with the some more type of transmission line such as strip line, microstrip transmission line. This is also a type of a transmission line. And after going through the transmission line, you will be introduced with the waveguide. As you are aware that the waveguide, already I think you have studied that in the semester 5th in the optical communication. In that also you are introduced with the word of the waveguide, because our optical fiber is a form of a waveguide. So, whenever the term waveguide comes into existence, the first thing which comes in our mind is that the waveguide means high frequency signal. Waveguide is basically used for the high frequency signal, which is basically our microwave signal or the higher signal. So, whenever if we are going to study about the microwave and radar engineering, so the first topic which we have to be aware is the waveguide, because it is the main transmitting medium which is used in the microwave signal. So, in that particular section of the unit 1, we will go through the different types of waveguide. First one is the rectangular waveguide, the second one is the circular waveguide, and the different aspect of that means we will study about the field components and the various parameters associated with that, and then we will move towards the modes T and TM. The name is already aware with you, that is T is the transverse electric and TM is the transverse magnetic. And after that we will same thing we repeated for the circular waveguide. So, basically in the unit 1 we will deal with the transmission section of the microwave engineering. And after that we have come with the unit 2. In the unit 2 we have to study and you will be taught about the various microwave devices, and that is also a passive devices, the passive devices which is not generating any signal. So, we will study in this particular unit about the various microwave passive devices. Some of them whose name is mentioned here, there is number of passive microwave devices, but which you are going to study in this particular semester is the first one is the microwave junctions and the couplers and scattering matrix. I think whenever when you are studying about the various network in the network theory subject, you are come across the Z parameter, Y parameter, ABCD parameter and etc. In this particular section, when we are going through the microwave, here we will have the scattering parameter or the scattering matrix. So, in each you will study about the various component, but you have to derive the scattering matrix of each of the components which you are going to study in this particular unit. So, before going through the components in detail, first of all you are make aware with the scattering matrix. What is the scattering matrix and how we are able to calculate the scattering matrix of the various component. In this section you will also studied about the different important characteristic of the scattering matrix. The microwave components then which comes into existence are the microwave hybrid circuit, terminations, attenuators, phase shifter. Then we will you will study about the ferrite components and how the microwave signal is propagated inside the ferrite components. And under that heading then we will study about the Faraday rotation also and isolators, circulators. Isolators, circulators name is written just after the ferrite, that because these are basically the ferrite components which are used in the microwave engineering. And of course, as already told to you, the S parameter analysis and the S parameter S matrix derivation of all the component will be done. Then comes the unit 3. In the unit 3 we will study about the microwave tubes. In this particular section, before introducing yourself to the microwave tubes, first of all I will tell you about why the microwave tubes comes into existence. Why not the conventional tubes such as triodes etc. are used at the microwave frequency. So, again I am repeating to you that before introducing yourself to the microwave tubes, first of all I will explain to you why the conventional tubes and vacuum tubes are not used at the microwave frequencies, and after that we will go through the microwave tubes. So, the first topic is also here, that limitation of conventional active devices at the microwave frequency, because unless or until we should know that what are the problems which arises in the conventional tube, we can't say that why we are using the microwave tube. So, the answer of why we are using the microwave tubes comes from this particular topic, and after that we will you will be introduced with the different microwave tube. The first one is the two cavity klystron, second reflex klystron, magnetron, travelling wave tube, backward wave oscillator, and of course, when we study about the different components, their schematic, their principle, their performance characteristic, their application, all will be go parallel for each and every microwave tubes. And after that we will have the microwave measurement as the unit 4. So, before going through the topic because in detail, you should know that if you go through the unit 4 in detail, you will be very much familiar with the microwave labs experiment which you are performing in this semester only, because the topics which will be covered in the unit 4 is comprises of the lab experiments also. Because if you are able to see here microwave measurement of insertion loss, the measurement of insertion loss is also included in the lab, also can be performed in the lab. So, frequency cavity, dielectric constant, scattering parameters measurement, noise factor measurement, return loss impedance measurement, and VSWR. VSWR stands for voltage standing wave ratio. So, for measurement of the output at the microwave frequency VSWR meter plays a very important role. So, we will go through this one, and after that we will have the power, we will study about the power meters, microwave amplifiers. So, basically all the things which are in the unit 4 is basically the components which are used for the microwave measurement and what are the common factors, common parameters which we measure in the microwave. So, that comprises our unit 4. Now, comes the unit 5. In unit 5, you are made aware with the radar system. So, we will have the radar here, and after that radar block diagram, radar range equation, probability of detection of false alarm, integration of radar pulses, radar cross section of targets, and now again after that up till this we have the general concept about the radar, and after that we will have the different type of radar, MTI radar and continuous wave radar. These are the two type of radar which are commonly used. So, this comprises of the 5 unit which you have to study in this particular subject. First, transmission line, second one is the microwave component, third one is the microwave tube, fourth one is the microwave measurement, and the fifth one is the radar. So, we can able to see that the subject name is microwave and radar engineering. The first 4 unit comprises of the microwave and the last one, 5th unit, is of the radar. Now, the textbook as prescribed by the university is the first one is the book of microwave devices and circuit, which is written by the Liao, and the second one microwave engineering first edition Oxford University publication written by author is the Susrat Das, and the third one is the introduction to radar engineering, third edition Tata McGraw-Hill, and the author is M.I. Schooling. And the reference book which you can follow is the microwave engineering first edition Tata McGraw-Hill by A. Das and S. K. Das. This is the book which you can refer for studying this particular subject. And now comes the course outcome. That means after going through the course, what are the basic thing, what are you able to learn. So at the end of this course, you will be able to demonstrate the ability to analyze various parameters and characteristic of the transmission line and the waveguide, and also use of the waveguide component as per application. So the first outcome which we can have after studying the subject, that you will be able to analyze various characteristic and parameters related to transmission line and the waveguide, and you are also able to use waveguide components as per its application. The second course outcome is describe, analyze and design simple microwave circuit and devices, example couplers, attenuator, phase shifter and isolators. These are the various microwave component whose analyze and designing can be done by you after going through this subject. And also students will be able to understand the microwave propagation in the ferrites. The third course outcome is the analyze the difference between the conventional tubes and the microwave tubes for the transmission of the EM wave. So, this particular course outcome can be achieved by you after going through the third unit. So, this can be achieved by unit 1, this can be achieved by unit 2 and this can be achieved by unit 3. And after that, the fourth course outcome is you are able to acquire knowledge about the handling and the measurement of microwave equipment. So, when you go through the unit 4, which is our the microwave measurement unit, you are able to handle and measure the various microwave equipment. And after the fourth course outcome is you are able to differentiate between the radars, because in this part, the unit 5, you will be taught with the radar, its principle, its working and its different types, an application, how it can be used and how it comes into, so all things comes into the unit 5. So, you will be able to achieve this course outcome after going through the chapter or the unit 5. Now comes the, till this I have introduced with you the basic syllabus of the microwave. Now, I am going to have the introduction of the microwave and radar engineering. So, the field of radio frequency, which is also known as the RF, and the microwave engineering covers the behavior of alternating current signal with frequencies. So, when we talk about the alternating current element, basically we are saying that E and H fields, current and the voltage all comes into existence over here in the range of 100 megahertz to 1000 megahertz. So, basically these are the frequency range of the RF and the microwave frequency. The RF frequency range from very high frequency, that is VHF, which is ranges from the 30 to 300 megahertz to the ultra high frequency, which ranges from the 300 to 3000 megahertz. So, these are the basically the range for the RF frequency, but when we talk about the specifically about the microwave frequency, the frequency ranges from the 3 to 300 gigahertz. So, you should remember this value, because it is always asked in the 2 marks or single marks question, what are the frequency range of the microwave signal. So, you should remember and clearly answer over this. And now, the terms come, if the frequency is high, then why the name micro comes into existence. So, micro now name is as per the wavelength, because wavelength, if the frequency is very high, as we know that wavelength and the frequency are inversely related to it. Again I am repeating, wavelength, which is given by the term lambda, is inversely related to the frequency. So, if we are saying that the frequency is on the higher side, that means wavelength is on the lower side. So, in this microwave range, frequency is on the higher side. So, the wavelength will be in the lower side. So, that is why the term micro comes into existence. So, the term micro is as per the wavelength of the microwave signal, not as per the frequency. So, the name micro is given to the microwave signal as per the wavelength, not as per the frequency. So, not to be confused ki why, if the frequency is so much high, why we are giving the name micro to it. So, micro means we are talking about the wavelength. And again, the most important, some important points related to this. The lumped circuit component approximation of the circuit theory is not applicable at the RF and the microwave frequency. So, we already know that basically there exist two type of components, which about that which we have already studied at the prerequisite in the network theory, that lumped components and the distributed component. The lumped circuit elements approximation of the circuit theory is not applicable at the RF and the microwave component. While the distributed element approximation of the circuit theory is applicable at the RF and the microwave component. So, you should remember this point. Microwave component often act as a distributed element. Already told to you that lumped component is not applicable. What is applicable? That is our distributed component, where the phase of the voltage of the current changes significantly over the physical extent of the device, because the device dimensions are on the order of the electrical wavelength. This is basically the reason why we are not using the lumped component and we are focusing about the distributed component in the microwave signals, for the microwave signal. Here comes the, whenever we talk about any type of signals or anything, first we have to be aware with the electromagnetic spectrum. So, here is the electromagnetic spectrum. So, in the microwave section we have not to go with the broad electromagnetic spectrum in the detail. We have to mainly focus upon on the this microwave band. So, if you are able to see L band 1 to 2 gigahertz, S band 2 to 4 gigahertz, C band 4 to 8, X band 8 to 12, Q band 812 to 18, K band 18 to 626 gigahertz, Ka band 26 to 40 gigahertz, U band 40 to 60, V band 50 to 75, E 60 to 90, W 75 to 110 gigahertz, and F band from the 90 to 140 gigahertz. So, you should remember this band with the frequencies, because this will be definitely very important and it is asked on the examination also. At the last we are going to have the sum of the application of the microwave signals. So, as the high frequency and short wavelength, high frequency and the short wavelength of the microwave energy make it difficult for analysis and design of the microwave devices. So, due to this unique features also, there are many applications which is applicable to the microwave engineering. The first one is the antenna gain is proportional to the electrical size of the antenna. At higher frequency, of course, the electrical size increases. So, more antenna gain can be achieved. So, this advantage of the antenna can be achieved on the basis of the unique feature of the microwave signal, that is high frequency. The second one is more bandwidth can be realized at higher frequencies. So, if the frequency is high, more bandwidth can be achieved, and it is directly related to our data rate. So, if the if frequency is high, bandwidth is high, and that related to the data rate will be high. And now, microwave signal travel at the line of sight. This is a very important characteristic which is associated with the microwave signal, that is travels at the line of sight and not bent by the ionosphere as the lower frequency signal. The lower frequency signal get bent by the ionospheric layer, but this microwave signal travel at the line of sight and did not bend at the ionospheric layer. So, this particular advantage, this particular feature of the microwave signal make it useful for the satellite and terrestrial communication with very high capacities. So, the features which is associated with the microwave signal provide advantage to it. First one is the increased gain in the case of antenna, increased data rate, more bandwidth, line of sight communication, which make it applicable for use in the satellite and the terrestrial communication link. Some more the application which I have discussed in the previous slide are the basic and the most important feature applications of the, these are some additional features and the application. The effective reflection area of a radar target is usually proportional to the target electrical size. In this fact, coupled with the frequency characteristic of the antenna gain, so as the electrical gain increases due to electrical size, Similar case with the radar also. Various molecular, atomic and nuclear resonance occur at the microwave frequency, creating a variety of unique applications in the area of basic science, remote sensing, medical diagnostic and the treatment and the heating method. So, thus microwave signals are also applicable for the remote sensing, medical treatment and etc. and heating. So, here comes the end of the lecture 1, where I have introduced you with the basic into the microwave and its application. Thank you.